Hello everyone, welcome back to the channel, and today we're going to be doing another USACO problem from the bronze round called It's Moving Time. Now, I first encourage you to go to this link and read through this whole entire section, maybe try to understand it, develop a solution if you can, and then come back and rewatch this video. So I'll allow you to do that. Okay, so I hope you read through the problem, and if you didn't understand, I hope this explanation helps. So what we're given here is we're given a string s, right, as our input. We're given string s, right? And we're saying that the length of this string is n, so its length is n. And we're also given a number f, which represents the amount of possibilities that this string can occur, right? And so now we have to think, okay, how does a moo occur, right? So a moo, first of all, is 3 letters, right? So 3 letters, right? And it's not just any kind of 3 letters, right? It has to be a specific sequence. So the specific sequence they give us is CI, followed by a CJ, followed by another CJ. So I'll just represent it as my own variables, X, Y, Y, right? So the last 2 letters have to be the exact same. And we are also given a subcondition that X cannot equal Y. So keep that in mind. This is pretty important. And it gives us some examples, like obviously moo is the most obvious one, ba, sick, you know. But there is a twist into this problem, is that there is up to, so at most, 1 character that could be wrong. So we have to take that into account when we're doing this problem. There's 1 character is wrong, right? And so what would our output be? Our output, now that we have all of the information up here, is all possible moves, right? And like that appear, output is, so just some key things, all possible moves, and it has to appear greater than the f amount of times, right? Greater than f. And they have to be less than like 1 change. So after has to be less than or equal to 1 change. So basically, just to summarize again, our task is to find every possible moo that could appear at least f times, considering that the original string and any string formed by changing 1 character can occur. And then we have to just print out how many such moos exist, and then we have to list in alphabetical order. So remember, we're not just finding how many moos exist, we also have to list them in a specific order. So now we have to actually figure out a solution that we can try to code, right? So let's just go down. Now, there are 2 ways you could probably solve this. And for USACO purposes, we don't want to brute force it, right? Because that would just be where we have to change 1 character and we have to recount the entire string, and overall the process would be far too slow, because a string could be as long as I want it to be, right? So our key main goal is here is that we have to change 1 character that only affects moves that include that character, right? And so since a moo is like, 3 characters long, right? A change in the position I that can only affect like the moves that start at the specific positions I minus 2, I minus 1, and I. So the change will basically happen at the I minus 1 and I, right? So what we could do is, now that we've represented them as an indice, we can basically just count all the moves in the original string, right? And then for each position, we try to change it to every single letter, and then temporarily remove the old moves and add the other nearby moves. So basically, this will let us to track which moves could reach the required frequency, and any moves that appear at least F times is saved as a possible answer. So that is how we can tackle this problem. And now let's go to Visual Studio Code. Okay, so now let's actually do the coding part. So first we have to include all the standard libraries, all the standard C++ libraries at once. And this will use the string, the map, the set, and the other things that we'll need. And this includes them one by one and would be long and unnecessary if we didn't have this part. So then we have to use the namespace, which will allow us to use the names like string, map, and set, without writing std in front of each and every single one. Now, after that, we have to introduce our main function, and this is basically the start of the program, and this is where it'll start to execute. And every single program has a main function. And next, what we have to do is we have to disconnect the C++ IO with the syn, count from the C I/O scanf and printf. And this would make the input and output a lot more faster and a lot more efficient. And this is important because the input size could be as large as possible, right? And then we have to do syn.tie for 0. This will basically prevent the code from flushing automatically before every syn. And this matters because it prevents unnecessary slowdowns and further improves speed. Next, we have to declare our two integers, right? The length of the string and the minimum frequency it can take. And we also have to declare the string, the actual string s, which is our variable that we use for the string. And then we have to read the input from the standard input. So basically read the length of the string, then the frequency required, and then the string itself. And this order matters because this is the exact order we need it to be for the next step, which will basically create a map or a dictionary, and it'll have a key for 3-letter string for all the possible different moves, and a value for how many times that move appears. And this is really needed because we need to store as many of the different moves as possible. And moves are strings, they're not like actual indices, so we can't use indices in this case. That's why we have to use a map. Next, we have to actually store all the moves that meet the requirement, and this will automatically remove duplicates, and this will also sort them alphabetically because you're storing them in a sort of set. And this output must be unique and sorted, right? So that's why you use the set to actually sort them alphabetically. And then we have to declare a lambda function, and this function will check whether a move starts at index I. And the reason why I use a lambda function is because we want the helper logic to close to where it will be used, right? We want to avoid the cluttering of the global namespace, so that's why we use the auto lambda function. Next, what we want to do is we want to prevent accessing characters outside of the string, right? So we don't want a move that needs like the 3 different characters, but the index is way too high, right? So we have 3 characters: I plus 1, and I plus 2. And this is really critical and really important because accessing outside the string would cause an undefined issue or a crash. So now that we did that, we want to return our first character, and we want to return the move definition, basically, right? We want to, where it says that the first character does not equal the second character, but the second character does equal the third character, and it will return true only if that conditions are met. If those conditions are met, it will return true. Otherwise, it will return false. And then we have to declare another lambda function, which will basically update the frequency of a move starting at the index I. And why we need to have an int for change, because a change will basically add a move or it can remove a move, depending on what needs to be done. next, what we need to do is, if no move starts with the indice I, then you basically will just do nothing. So that's why we return nothing, and we want to only count the valid moves. So this will basically remove all the other moves that just start with an I, or that don't start with an I, excuse me, the indice I. And so if they don't start with the indice I, then it's not a valid move. And next, what we want to do is extract the 3 character substrings starting at I, the indice, right? And this is like the actual move itself. So you'll get a list of all the different moves. And next, what we want to do is update the count of these moves, right? And we want to add or remove like specific occurrences. And so we want to have our count and then sub plus equals change, right? And then what we want to do is, if this move actually appears at least F number of times, we want to add it to our final set. So we have our if, and we have our count with the sub is greater than or equal to F, right? We're counting for it appears at least F times, then result, and we would use the insert function to actually add it to our final answer set. And now we need to basically update all the moves that are affected by the change in position. So we use one of the lambda functions, and we want to have a move that is length 3. So any move that touching index I must start at I minus 2 or I minus 1 or I, and no other positions would be affected. So that's why we need to have the update point for each of those. And then we want to have our update range, right? We want to end our update range function. So this is the whole entire update range function. And then what we need to do is we need to scan the original string. So we want to count all the moves that are initially present. So we have our for loop, and we'll basically have our update point for only the indice comma 1. So we want to count all the moves initially present and scan the original string. And then we need to modify each character one by one. So we'll run it through another loop, and we'll actually save the original character inside this loop, and it'll allow us to restore the string later. And then we need to make one more loop, which will try to replace the character with every single lowercase letter. And then we want to remove the old moves affected by the position I. Right? So we want to have our update range. And then we want to temporarily change this character. And now we can add a new move created by this change. And then we can update another range and remove moves from the last try letter, and it'll restore the original character and re-add original moves. And so then we just need to print the amount of valid moves now, and print all the moves with the no constraints and already sorted, because they'll be already sorted because the set will keep the order. And then you should have your answer for both with the constraints and without the constraints. So I hope you enjoyed this video, and I'll see you next time.